We all have been taught in our primary schools that light is an electromagnetic wave until we came up with the word photon. That's where we got confused that whether light is a wave or a particle. So, starting from 1801, a famous scientist Thomas Young performed a double slit experiment in which light from a source gets diffracted while passing through the slits and an interference pattern is observed on the screen ahead. This is due to the superposition of the two diffracted waves. The brighter bands on the screen are due to the constructive interference of the waves, which occurs when the waves are in phase to each other, whereas the darker bands are formed due to the destructive interference of the waves when they are in antiphase. This experiment clearly proves that light is a wave because both diffraction and interference are the properties of a wave. Later in 1887, another scientist named Heinrich Hertz first observed the photoelectric effect. In this phenomenon, when light is shown on a negatively charged metal plate, the plate actually loses its charge, indicating loss of electrons, or rather photoelectrons. Using the quantum theory and Planck's idea that light exists as quantized particles called the photons, Einstein concluded that light is a beam of particles, the photons, and the energy of the photons is directly proportional to the frequency of the light. Hence, he derived the equation energy of photons is equal to the frequency multiplied by the Planck's constant. This equation is proven true because photoelectrons are only emitted when light with a certain minimum frequency is illuminated, as greater frequency means greater energy of photons, therefore greater energy gained by the electrons to escape the metal surface. The observations of the experiment also disprove the wave theory, which suggests that a brighter or a longer exposure of light would cause the release of photoelectrons regardless of the frequency. A wave or a particle? Well, there's something else that can prove light as a wave. Polarization. Imagine if an unpolarized light, which has its vibrations in more than one plane, is passed through a polarizing filter that transmits light with vibrations in one plane only, which is vertical over here. The light transmitted would be polarized to have vibrations in that single plane, and a dimmer light is what would be observed. Now that is something that cannot be proved by the particle theory of light, which means a plus point for the wave theory. Although we just saw that there is more evidence to prove light as a wave than simply a beam of photons, but the physicists agree on the wave-particle duality, which concludes that light at some situations behaves like a wave, yet at others it exhibits the properties of a particle. Therefore, it is declared as a quantum entity.